instrumental in establishing research support service at CSIR NL, where wide band of information services such as literature, novelty search, document delivery service, reference management service, plagiarism check, infographics design, etc. Joining to CSIR NL served DRDO, TRDC, Premier Research and Development Laboratory under Ministry of Defense, Government of India. It transformed National Library of TRDC to Digital Technical Information Center in a span of 6 years. He also as NCSI part of team which established India's first open access institutional repository, e-prints at IISc. Information portal designed at cater design digital information needs of IISc faculty way back in 2002. He is serving as a governing council steering committee member GPU, Human Resource Consortium, member of Creative Floor Committee, taken responsibility of establishing expert member for JNTU Anandapuram. Was research person various national and international workshops on digital and SCI journal. Recently, he has been awarded
participants, I request you once again to mute our mics. Audio and video should be muted. It is a request once again. Has been heard here. Please mute your audio and video. Okay, over to you.
Yeah, thank you, Dr. Krishna Prasad, for your nice introduction. So at the outset, I would like to thank authorities of Bibliographic of Technology and our senior colleague Dr. Venkateshwarlu for suggesting me for this session and allowing me to share whatever knowledge I had. So at first, I was going through your webinar brochure, so they are mainly focusing on research project proposal writing and so on. So what I will do, I will not be talking much on research proposal writing, so I will be talking more on research information discovery. So without any information, without any understanding of a research area, so it will be difficult for researchers to pursue research, go ahead research in their domain. So let's understand from this 1.5 hours, so what are the avenues available for research information discovery, what are the tools available. As a researcher, you can look on these resources and get understanding of your research area, and then you can start proposing a research work to any agencies where they will fund your research. Okay, and as I see, there are more than 200 participants, and I understand all are from academics. So if you are all from teaching profession, if you are engaged with your regular teaching and also you are asked to do research, I think this is your position right now. So your institute or your management will assign your regular academic activities and also insist you to carry out research parallelly, right? They have their own requirements because now all accrediting ranking frameworks. So they are looking at various metrics, which also includes that publication metrics or scholarly metrics, what you produce, what you publish. So I understand this is your situation, and unfortunately you have only 24 hours in a day. So again, you have to divide that 24 hours into your personal needs. Of course, whatever you are doing, that is to take care of your personal life, your family, your kids. So I assume that any researcher or any academician who will be spending around 10 hours to 12 hours in an institute maximum. So you have to manage your academic activities and research activities at least 12 hours or 8 to 12 hours. So if you take any research activity, it again involves lot of jobs, like you have to do literature search, you have to get hold of relevant content, and you have to do experiment, you have to write that, you have to report that, etc., etc. So how efficiently you can manage this available time? Now you have a lot of resources, lot of tools available for researchers, of course in open access domain also. So I will try to bring you one notice that these are the tools which as a researcher you can employ in your day-to-day research life, so that your life will become easy and you can manage your time more effectively. So as a researcher, of course, you have various activities on your research path, like you will start your research with literature search to understand your domain, understand your research area, and you have to come up with a suitable problem which you are going to execute, which you are going to conduct research on that particular problem, and you will do experimental or modeling or simulation, whatever is suitable for your research. And you start reporting that research in terms of your journal articles, or conference paper, or thesis, or any sort of reports. And also later part, you have to address various issues like the similarity. Now there are mandatory clause. Your research report should not have any similarity, and also your institutes may expect some publication metrics. So these are the various hurdles you have to do as a researcher. So what are the stages of research? You have various stages. If you take any research problem, if you want to solve any research problem, possibly today's presentation, in my presentation, I will be addressing you to literature search and how to manage that, the relevant content, relevant scholarly literature for your research. And if time permits, we will also see what are the reporting, research reporting formats, and what are the tools available for that. Okay. So how do you identify a research problem in your research area? So one thing, you may start with consulting various bibliographic databases where they aggregate a lot of content from various scholarly sources and bring it to you at one place. You start your research literature search by abstract databases or bibliographic databases. Then you go on to scholarly literature, that's basically full text journal articles or conference papers, and you go through, you narrow down to a specific research area, and you go through in detail by going through those material, and you identify a research problem. So other way of identifying research problem is you do consult a lot of patent databases where you can explore patent in your research and what is the trends in a particular domain. Research
Technologies Day.
So research activity. So these are the various way as a researcher you can identify your research area. So we will see one by one what are the resources available in each area and how best we can make use of these sources. So in
CSIR.
that's before internet came, that is pre-internet era. So all researchers used to visit libraries and they used to consume a lot of print resources, print abstracting and indexing databases, and they used to get hold of information. And then they used to consult the full text in their libraries or nearby libraries. When internet came, everybody's focus shifted from, if not everybody, a majority researchers focus shifted from traditional libraries to internet-based resources, and they used to land up on internet for their literature searches. So parallelly, libraries also started acquiring a lot of e-resources on various journal publisher content, various aggregator content, and databases, so on. So now the present librarian's role is a little tough, that they have to reorient the internet-based internet-savvy research users to library resources. That's the real challenge they have. So this is the amount of content which is pumped into internet in every minute, every 60 seconds. You can see the numbers. Millions of bytes data has been pumped into internet now. So earlier there was an issue of getting access to information. Now the present day researchers are overloaded with information, right? So now the real challenge is how to get the relevant content from this ocean of information. So for example, if you are a VTU researcher, a VTU academician, you have access to your own institute library content and VTU consortium resources. They are spending somewhere around 20 to 25 crores of rupees every year to enable access to scholarly content published by various publishers. Apart from that, you have open access content. You will see what is open access content in later part of the presentation. You have a very good scholarly nature which is available free of cost. So you, as a researcher, you can also look into this kind of resources. And also we have a deep web or invisible web content. Whatever Google gives you, maybe 25 to 35 or 40% of content which is there on internet. There are a lot of content which is hidden behind databases, paywalls, or user ID passwords. So your relevant information can be anywhere. So now the challenge is how do you retrieve that? So for that, any tools or techniques available, so that in the least possible time you should be able to get the relevant information what you are looking for. So that's the real challenge now. So what are the tools available for you? If you are an internet savvy user, you come up with various search engines, meta search engines, specialty search engines. You have web directories, portals, and gateways. So let us see what are these. So I request
Participants, please mute your mic.
Dear participants, please mute your mic. It's disturbing other participants.
Please mute your mic.
Okay. So as a internet user, definitely you will go and land up on search engines, and I'm sure 95% of internet users will go and land up at Google. So that's the phenomenon. So everybody thinks when we go to Google, we will get everything. Equally, good search engines which you can consult, like Bing, Ask, Yahoo, they have their own algorithms and indexing systems to crawl the web and index the content available on websites. Basically, search engines are again a kind of a program which crawls and which indexes keywords. Whenever user searches that, so it points to the original website or original web source. Okay, so these are the various popular search engines one can make use apart from Google. And there are some meta search engines which are available again free of cost. So what do you mean by meta search engine? Again, when a user searches a search background, it will be searching various search engines, and whatever result comes, it will deduplicate and organize in some number of times that particular keyword is repeated, and it will throw you results. So these are the various popular meta search engines which are available. And there are some category of search engines called specialty search engine, where they do value addition whatever results you get. For example, here search.carrot.org, what they do, they they group all related results into one as a subject or a keyword category. For example, when you search for an vibration control in aircraft, so all whatever results they have got, they have grouped under engine, active noise, active vibration control system, so on. When you click on this web, so it will retrieve only those search results. Okay. Similarly, some research, some specialty search engine may group as a chronological order, year-wise, this, so that you can go from latest to old or old to latest. So they do some value addition. So, for example, if you take a general search engine like Google, like everybody, I will also go and land up in Google and search relevant information which I need for my research, which is flight mechanics and fighter jets. This is the area where I'm going to pursue my research. So when I give my keywords, it throws me out 12 million records. So it's highly impossible for any researcher to go through 12 million. It's impossible, right? We may go up to 10 page or 20 page, per page 10 records. So we end up frustrated, we give up. So whatever Google gives, 90 to 98% is noise. Okay, it's only indicative information, not the informative information which we are looking, right? So you also would have experienced the same experience. So of course, Google also provides some filtering options, like some advanced search options, like it also supports phrase searching. For example, fighter mechanics, I will put it in quotes and it will be treated as one phrase, and fighter jets as one phrase. So now from my 12 million records has reduced to 7,000. Again, it's impossible for me to go through all 7,000, which may be relevant, which may not be relevant, right? So again, I want to filter. So again, I go to advanced search options, like I will filter by file type PDF. I assume that files contain some relevant information so that I can consult those things. So you can restrict, and it throws me up around 216, which is quite possible for me as a researcher to go through that, right? And it has got some other advanced search option. Of course, I know everybody would be aware of this, and you may be using these tools. And also there are various search tips, like you can employ advanced search, Boolean search operators, as phrase search as I showed there. And you can also truncate if you are getting very few articles, so that you can broaden your search. Yes, and you have a skill-based search, and your whatever theme, whatever topic you think should be title as an abstract, you can have a place. And also various filters like chronology, file type, etc., which may be there in almost all search engines and meta search engines. Now the real problem is, that's the layman approach. Any common man who knows internet, who are familiar with internet, will do that. But here you are an engineer, you are a researcher, and what you are looking at is a scholarly content, not that general information which is not authentic, which is thrown out by any search engines, right? So how do you get to scholarly content? Scholarly content which will be useful for my research. This is a real challenge now. Today researchers are facing with the information overload, right? So first, let us understand what is scholarly information. So what is scholarly information? The information which is created in the course of research activities, like whatever experiments you conduct, whatever research findings you find out, you will be reporting them in the form of conference paper, in the form of journal articles, in the form of book chapters, etc., etc. We can term that as a scholarly information, right? And also this information, whatever you publish in this form, should be validated by the domain expert. Like if you submit an article to a journal, there will be an editorial review process, right? Experts will review your research findings, whatever you have reported, whether really authentic. Okay. So they validate whatever things you have communicated. I think somebody is the clock. Yeah.
Can we, mute the participants?
So domain experts will validate your research, right? Validate your research findings. So that we can call it as, that we can term as a scholarly information. and also this information is published in a regular framework. Okay, so regular framework in the sense it may be a journal, or it may be a conference proceedings, or some open access platforms where some reputed institutes are made. This we can call it as a scholarly information. So if you look at this scholarly information, these are categorized, mainly categorized into three types. One is primary resources, where you find the first-hand information, where researchers has published the first-hand information. Whereas a secondary information sources are coming from the primary. After consulting primary information, they will publish them as a second information sources. Mainly, to name few, they are the edited books, manual blogs, and all. Primary information sources are scholarly journals, government reports, and so on. And we have one more category of resources. They are the tertiary. They are like a ready to refer, ready reference sources like your encyclopedias, guidebooks, etc., etc. As a researcher, I will be more interested to consult only the primary sources information to understand my research area. Right? So what are the scholarly information document types you come across? As I told you, journal article. In journal itself, you see various type of articles. One is a review articles, usually published by experts in that domain. So they will review a wide band of journal articles which are previously published, and they will give the direction where that particular domain is going. So you can consult these review articles. You can also consult original research articles published by the researchers. And also you may find case studies and rapid communication as a small 2 to 3 page publications in journal articles. Of course, these are the other type of primary sources like conference papers, book chapters, government reports, case studies. Especially in management domain, you find a lot of case studies which give more insights to a researcher. And do you know the volume of scholarly information growth? Forget about the other information which we find on general search index. Scholarly information source itself doubles in every 9 years. That was the report published in Nature News in 2004. Now maybe it would have reduced to 8 years. And there are 33,000 English language peer-reviewed journals published across the world, and there are 9,400 non-English language peer-reviewed journals. When I say peer-reviewed journals, indexed at some science citation indexes like Scopus on Web of Science, or they have established a well-established peer review process. And there are so many other journals which are not indexed at these citation indexes, or we come across a lot of open access journals, but we'll talk later. This statistics is as per 2018 STM report, Science, Technology and Medical report, published every year. So this is this statistics as per that. And I have taken a data from one of the well-known science citation index called Web of Knowledge platform, where they have millions of documents indexed on their platform. So you can imagine in scholarly information, the volume of scholarly information itself. If you see the statistics, number of papers indexed at these scholarly databases, definitely I am sure you are aware of Scopus, which indexes content of 5,000 publishers. And right now they have more than 700 million article data indexed on their platform, and they also capture citation data. Who are citing these articles, so that authors can come to know that who are all citing their data and who are all working in this area. So similarly, Web of Science is one of the oldest citation database since 1950. They have 161 million article data on their platform. So you can imagine the volume of content available for you. Now, fortunately, with the advent of these digital technologies, these are available on your device, on your pocket, on your fingertips, provided you have access to that, right? So this is the growth of articles in Scopus. So these are the number of articles indexed, around 3 million in 2017, and the number of citations received. Number of articles received citations is also somewhere around 2.5 million. So this is the growth. Now, So what are the platforms? What are the resources as a researcher I can look for scholarly information? So you have something called scholarly search engines. We will see that what are those, and of course you have your library resources. You have open access content. You have patent resources. You have a variety of platforms which you can make use to discover whatever relevant information you are looking for. So we'll try to see one by one what are these and how best we can make use of our research area. So instead of what I suggest, instead of using general search engine, always as a researcher, you can always focus on using scholarly search engines. Again, what are scholarly search engines? They are nothing but search engines, but they focus only on indexing content which is scholarly in nature. Either it can be a journal article, or it can be a conference paper, or a book, or a report. So they restrict only to the scholarly content, not the general, right? So popular scholarly search engine or Google Scholar we have. So we will see the features of Google Scholar. We have a Microsoft academic search, again a Microsoft product, and we have a Crashcraft metadata search. Is an interesting initiative by publishers. We will see what is that, and we have a Get the Search. Again, it's a free platform for open access content, and Base is again an excellent platform for open access content, right? So we will see one by one what are these. So this is a comparison between Google and Google Scholar. So in Google, I use same keywords like flight mechanics and fighter jets. I got 12 million, of course, out of which 98% is noise, right? In Google Scholar, same keywords I have used, I have got only 17,000 articles. So these 17,000 articles are, again, they are only a scholarly content. You can see here, there is a link to a PDF file. Either it may be a journal paper or a conference paper or a book chapter or whatever it is. Again, you can follow that phrase searching or filter options which Google Scholar provides, and you can minimize the 17,000 to your narrower topic, right? So if you dissect one Google Scholar result, so there are many more advantages. For example, I am looking at information on fighter jets and flight mechanics. And as you all know, and most of you have created a Google profile, right? If you have a Google account, you can create a Google profile free of cost, and you can integrate all your publications there. That's called as a Google author profile. It also captures all your citations which are available on Google, right? So this is, for example, I'm looking for articles on flight mechanics and fighter jets, and I have come across of this particular article, and there is one first author. It's called S. Quota, and fortunately he has created a profile, Google profile, and he has integrated all his articles. So when I click on this quota, so it opens up into a Google profile, and whatever articles written by quota, it has listed everything. So definitely quota is working on flight mechanics, right? So my search strategy in one click, now I am able to get a lot of articles on this particular topic. Similarly, if it is a multiple authors, if they have an author profile, you can get hold of all their articles, and possibly if they have linked to full text, you will directly land up in a full text and download it. Okay, and you come across various social networking platforms like the Research Scholar or Microsoft Academia, where author can create profile and they can link their full text access as per as publisher copyright norms. And if that is available on their domain, Google Scholar will directly link to that particular PDF. And if you click on PDF, you will straight away get the full text without paying anything. And also, Google Scholar offer you much more functionalities like cited by 110. This article is used by 110 different authors. Definitely, they are also working in the same area, right? So if you click on this particular link, it throws me up 110 articles which cited by this article, which they have cited, right? Definitely, they also may be relevant to me, so that I can look into those 110 articles. And there is one more provision called related articles. Based on the keywords what Google Scholar has retrieved, it itself analyzes and throws you related articles in this particular domain. If you click on this related articles, it will bring you the article relevant based on the keywords which all these articles has got. And also this particular article is available in 7 places, 7 different places. Maybe it's an institutional repositories or subject repositories or author platforms, other social networking platforms or publisher site, so on. So if you click on these 7, it will take you to the at least metadata level wherever it is available, and it will redirect to the full text on wherever that particular full text article is present. So you also have a site. Okay, most of you would have published several articles, and at the end you give a references. What are the sources you consulted to report this research? And those citations will be on standard format like APAR, AMAR, IEEE, and whatever for standard format citation style your publisher insists. So Google Scholars allow you to directly export in those style formats and import it to your report or your thesis or your journal paper, right? So these are the various functionalities you can explore, and I'm sure many may be using this. Those who are not using, kindly you can have a look at this feature so that it will save you a lot of time, right? Okay, similar platform is Crossref. Again, it's a not-for-profit initiation by various scholarly publishing firms like Elsevier, Springer, Taylor, and Francis, and all majors who publish scholarly content. And what they have done is they have shared their metadata up to abstract level content with Crossref, so that whenever you search, you will be searching all publishers who are all the members of this Crossref. You will be searching all members' content at one place. You need not go to Elsevier site, or you need not go to Springer site, where they will be limited to only those publisher content. So it becomes publisher independent content. You will search only publisher content here. For example, if I am looking at cloud computing is my research area, and I want to see what are all the papers which are published in cloud computing, irrespective of any publisher. So I can go and enter cloud computing as a phrase here, and I got so many results. And these are all the publisher content. No other irrelevant content will get. In this also, you can have a various publication types like journal paper, book chapters, reports, etc. If you restrict only journal paper, there are 1,94,000 papers on cloud computing, right? So you can fine tune your research. There are various advanced search options in Crossref also. Maybe you can make use of those, and you can narrow down your search results. As I was telling you, Base. Base is an excellent search engine for open access content. So when I say open access, I think I have a slide in the later part of my presentation. I will tell you what is open access, why open access came into picture, and why people are publishing in open access, and funding agencies are insisting their researchers to publish in open access. So right now we will try to understand what is Base. So Base is an open access based search engine which has got more than 100 million documents from 5,000 sources. And the happiest part of this Base is that 60% of the content is free to use, free to download. You can get it free with any cost. For example, if you want to purchase any article which is published with Elsevier or Springer, somewhere you have to spend somewhere around 3,000 to 4,000 rupees, right? If that article is very relevant and you are in a very much need. So if you search this Base search engine, you may get it free. Of course, it may not be a published version. It may be an author version. We'll see what are that. And it contains a metadata of academically relevant sources like journals, institutional repositories, digital collections of author personal collection, and so on. And it also indexes deep web content. When I say deep web content, it's behind user ID passwords, like I told you, institutional repository which may not be open to a general search engine. So this Base indexes this institutional repository with a special protocol called OAPMH, Open Access Metadata Harvesting Protocol. So what it does, it goes and it talks to these institutional repositories or subject repositories, and it indexes that content which is embedded with the user ID password. So it's an advantage for you to get deep web content. It has got excellent filters. For example, you are getting a large number of results. So you can narrow down to a specific by applying various advanced search option what Google what base provides, right? So this is how your base interface looks. So you can either go by document type, or you can search field based. You can search whatever document type you want, and you can have a time frame here. And also, like as I told you, open access content. In open access there are various copyright clauses like CC by SA. These are the various provisions open access has made. So you can search from that. So why I am insisting base is, for example, in 2019, as a VTU consortium couldn't afford IEEE because of their cost purpose. So they demanded somewhere around 14 crores for only IEEE. So VTU colleges were not able to access this IEEE content. For example, any researcher who is doing on cloud computing, he is in a need of article which is published in IEEE Cloud Computing Journal. Unfortunately, you don't have access. Otherwise, if you want to purchase this article, you have to pay around 3,000 to 4,000 rupees. Depends on the publisher price. So now, if you employ this kind of platforms to search, this particular article, Cloud Interoperability Challenge, is published in IEEE Computer Society, okay, journal, and it is published by some Australian research group. Okay. Unfortunately, this article copy, maybe author copy, they have deposited in this particular Australian National University digital collection. It's an Australian National University repository, and they have made it open free of cost. Okay. So as a researcher, you will be able to get that particular article, which may be very core article for your research. So this is the advantage of searching this kind of platforms. And there is another one called Science Open. Again, what they claim is they have indexed around 25,000 journal articles from 3,200 small publishers, maybe a major publisher and a small publisher. So advantage here is, if it is a commercial publisher, you may not be able to access the full text, but if it is an open access article on commercial publisher platform, also you may find some open access article, maybe 5 to 10% of their papers are open access through author pay charges. As an author, they would have paid, and it would have been made an open access for readers. If they have that kind of provision, you find particular icon. This icon means it's open access, though it is published in Elsewhere or Springer, but it is available in open access mode, so you can directly download that particular article and make use for your research work. So this is the advantage of having Science Open. There are other category of information sources. Of course, they may not give you full text content. They will give you the access up to abstract level. So what are bibliographic databases? Again, kind of a database where it will have an organized digital collection of references published by various journal articles. So why we need these bibliographic databases? Of course, now since all publishers are going online, the relevancy of these bibliographic databases is coming down. So why there was a requirement for bibliographic databases? Like we know all major publishers who publish around 80% content by 4 or 5 publishers, say IEEE, Elsevier, Springer, and they have their own platforms. There are various other smaller publishers who don't have their online platform to expose their content. So as a researcher, whatever information you are looking at may be hidden in any publisher, not necessarily with the major publishers, right? There may be a journal article published by INSA or our Indian Academy of Science, or there may be some small society which is not part of any online platform aggregators. So it becomes very difficult to reach out the research community. As a researcher, it may be I may ignore of those publications. So these bibliographic databases, what they will do, they aggregate data from these smaller publishers, and they index, they organize systematically so that researchers can search this and they can get hold of this content which is published by smaller publishers also. For example, for engineering domain, we have called Engineering Village. right? So they cover journal article data from 190 engineering disciplines from 73 countries. And they cover somewhere around 3,800 engineering only journals published by 1,988 publishers. Those majority of them are smaller publishers. They may have 1 or 2 journals, right? And they may not have an online platform to expose their content. And they also include 107 trade magazines, 83 plus conference proceedings which are published in engineering domain of 190 disciplines. Okay, so that is the advantage. If you do a literature search on this kind of platform, at least you will come to know such a paper has been published in my area. Then I will approach my library or the author or some other platform to get full text of that paper. And fortunately, if your institute has got access to that particular publisher, automatically link will be there. If you click on that particular link, it will go to the full text paper, so that the discoverability will become very easy. For example, if you're working in physics, electronics, computing engineering, mechanical, you have a database called InSpec, again, which covers more than 5,000 scientific and technical journals, 2,500 conference proceedings and series of conferences. So at one place you get a lot of information, maybe up to abstract level, and these bibliographic databases are basically subject oriented. For example, if I am working on aerospace, I have an aerospace database. If you are working in a chemistry, you have a site finder or a chemical abstract, which is quite popular, and they allow structure search also. So advanced search option. And if you are in agriculture, you have a Agris. If you are a biological sciences, you have a Boyces, medical Medline. You have various bibliographic databases. And we have one more category of databases called citation database. These are basically bibliographic databases. They have information up to abstract level. Apart from that bibliographic content, they also capture the citation data. So what do you mean by citation data? For example, I have written a paper, and that paper is used by some 10 other people. So my article citation will be 10. So they will they will refer my paper and give that reference in their references of the paper what they published. So that kind of data will be captured by these citation databases. And of course, whenever these accrediting agencies or ranking framework agencies like our NIRF or QS ranking or a Times ranking, so they also look at this kind of citation data. What is the impact of your research, what you have published? So they take data directly from here and they consider for awarding a rank or a grade point for an accreditation, etc., etc. So the popular citation databases are Web of Science and Scopus. They are the commercial databases, and they collect data, both citation data and bibliographic data from so many resources. And to include the particular resource in these databases, they have a third-party evaluation. So they evaluate each by each source, and they have a various parameters. And that, for example, a journal has to be indexed at this Scopus, means the third party will evaluate that journal with various parameters. So what I heard is Scopus considers around 20 categories. So journal has to meet the 20 categories, then only that particular source will come to this Scopus index. So why I'm telling this is whenever these accreditation agencies are ranking framework, they only take data from citation data from Web of Science and Scopus because there is a quality aspect. So there is a committee which has evaluated the sources where people are publishing, and they consider only that. For example, if you look at your Google citations, always Google citations will be more than the Scopus and Web of Science. If you have created Google profile and if you look at the citation count. So always people say in Google I have more citation, in Scopus I have less. Which one to consider? Definitely any decision making bodies like any award committees or any, if they want to award a project for you, so they also look at this kind of data, whether really you have established in the field, whether really you are capable of handling this project. So that kind of data they take from this. So the citation databases are very important source. Always you can also search for literature with this data, these citation databases. Of course, Web of Science and Scopus are quite expensive. Institution should be able to afford, not individual cannot be able to afford, because Scopus for somewhere around 15 lakhs per annum per year per institution. So similarly, CiteCRX is again a coming up open source based citation citation index. Of course, it's not complete like the Scopus or Web of Science. They have started in open access domain. Of course, you can have a look at CiteCRX, and one more advantage of CiteCRX is they link to full text paper which is available somewhere in institutional repository or an open access journal or author paid open access journal, something like that. So these are the again other type of information platform or information resources as a researcher you can look for. So there are other platforms called aggregators. As I told you before internet, there used to be a bibliographic databases. The same functionality is now done by aggregators on online platforms. For example, so many smaller publishers may not have online platform to expose their content globally. So what these aggregators will do, aggregators will talk to these smaller publishers and they will have a MOU with these smaller publisher, and they take their content and put it on their platforms. For example, Ingenta Connect is again a very popular science and engineering aggregator where they have more than 10,000 journal titles. Of course, they will have an archive collection also, previous volumes also, and they have 290 plus publisher content available on their platform. If you look at management related aggregator, we have a popular ProQuest. Their main strength is on management area. Similarly, we have a Project Muse. JSTOR, they have a content published in somewhere around 1900 or 1800. So they're very old archive collections they have. So if you are looking for an archive, really old collection, JSTOR will be able to give you. We have a HiWirePress. These are the popular aggregators. Okay, and this, if you use this aggregator up to abstract level, you can search for free, and for full text, of course, you need to subscribe these platforms, right? And again, we have publisher platform. Only limitation is that you will be searching only that publisher content. So you are limiting to publisher content, and you have to go each publisher site and search them. For example, Science Direct is a platform by Elsevier where you can search them 4,000 plus or 5,000 plus journals in one stretch. Okay, published by Elsevier. Similarly, we have a Springer Link, we have a Wiley, Emerald, and IEEE digital library where they have IEEE journal, conference papers, IEEE standards. So individual site you have to go and search. So this is all about journal publications, which we call it as a primary resources, and there may be other information sources like books, secondary sources. Those are also play an important role in our research area to understand our domain, because again, these books are written by some experts who are there in the domain. They would have reviewed so many primary sources and they would have come out with a gist of, and they are publishing as a book. So how do you know that these are the books available in my area, right? So recent books, of course, I may know by various platforms like Google Books, Amazon, or some other publisher, ebook publisher platform. So there are library catalogs like various international initiatives where you can look and you can search for a book in your domain. For example, Library of Congress is a national library of the United States of America where they have cataloged around 17 million book titles. Okay, so when you search this, at least you come to know, so what are the books published in my core area that I must have, otherwise my institute library should have this kind of collection, so that you can recommend to your library to purchase that book, which is a fundamental, which is a core book published by a reputed international author. So if you search Library of Congress, you will get access to 17 million catalog entries. That means up to bibliographic data. And we have one more MHRD funded initiative called INDCAT, where they are aiming to integrate all university library catalogs into one place. For example, we have a 900 plus universities, including private, deemed to be universities, and that INDCAT project aim is to get catalog content from all these libraries and put it in a single platform. So when you are searching INDCAT, you will be searching right now 176 Indian university content has been integrated. So when you search and indicate, you will be searching 176 university library catalog at one platform. So you may find the book which you are looking for nearby university, say Bangalore University or Mysore University or Tumkur University. Maybe you can drop into that particular library. If that book is very relevant, very much required for you, you can take a photocopy and you can use it for this. So these platforms will tell you what are the books at least published in your area. And now we are in a digital era. So we look at a lot of ebooks are available. So a lot of publishers are also emphasizing on ebook collections, right? So if your institution is rich enough to offer those books, yes, definitely it's in a welcome, so that you can have access to those ebooks. And last year, VTU Consortium has subscribed around 12,000 ebooks from Elsevier, Taylor and Francis, and Pearson, and Tata McGrath. So those are all again integrated to all your library portals. So there are some platforms which have digitized copyright-free books. For example, Internet Archive of Books, which gives you access to 1 million full text books. I'm not saying you will get everything. So these are the platform where you can explore and you may get something. So that's the point. When I say copyright-free books, as you all know, copyright of a book remains from the death of last author. If it is a multiple authors, the last author's death, from their 70 years, that particular publisher will have copyright, and after 70 years, it becomes a public document. So anybody can use free of cost. Anybody can digitize and put it on their websites. So it's basically a public document. So like that, there are 1 million full text books which are very fundamental. For example, all Shakespeare books are copyright free now. So you may find all Shakespeare books on the Internet Archive of Books. So they have digitized by taking funding from NGOs, or somebody would have funded it, and the Internet Archive has almost 1 million plus full text books free of cost. And we have National Digital Library project, again MHRD funded project. They have access to World eBook Library. For Indian researchers, they can become a member there and they can start accessing that. And also they are aggregating the research output produced by various research institutes, universities, and other colleges which have produced literature, like in terms of institution repository content, in terms of journal papers. So all those they are aggregating and making as a single index, so that anybody can search this information. And also there is an interesting project on Google, executed by Google, called Project Ocean, where again they are digitizing these copyright-free books and making available on the Google platform. Of course, a lot of publishers have come forward to put their ebooks on this platform. Of course, only few chapters they will open as a business model, as a sample of that particular book, so that you can read those chapters. And if you are really interested in that chapter, you can go back and purchase for your library or your personal library. So these are the platforms. There may be several other platforms. These are the interesting and mainly used platforms for discovering ebooks, right? And you have a publisher ebook platforms also. And throughout my presentation, I was referring open access content, open access term I was frequently using. So what is this open access? So open access means it's freely and permanently available on internet. Okay. So what is the philosophy behind open access is, for example, in NAL, every year we are publishing around 150 to 200 SCI publications, which are published with a reputed publishers. So now, to read those papers as a reader, you have to pay this commercial publisher, which is published by NAL. So how we are publishing? What is our financial support? Again, we are getting a funding from Government of India as a research grants. So from where Government of India is getting money? Again, it's your money, right? You are paying a tax, and so that Government of India collects that tax and fund her. So again, the same research work published by your money, again, if you want to access, you have to pay to publisher. Is this justified, right? You have to pay 2 times. It's a double payment, right? So when internet came into existence, lot of thinkers, scholars who are into this area, they thought why we should pay 2 times, right? So the main philosophy behind open access publishing is any research output which is published through public funding should be available free for public. So that is the main philosophy of open access publishing. So with this philosophy, there came open access journal called Gold Open Access Publishing, where researchers will directly publish in open access journal. Then as a young researcher, whenever I go to interview, whenever I apply for a project, whenever I apply for a award, so all decision makers were looking at the publication metrics, the journal metrics, where he has published, what is the impact factor of the journal.
You can see that the two-step method. We will use different processes to produce nanoparticles. Firstly,
so kindly mute.
Particles is dispersed properly and it is stable.
Hello, please mute your mic. Participant, please mute your mic.
Better stability. We will add surfactants.
Sir, kindly mute your mic. It is disturbing others.
Hello.
Hello.
Kindly, participant, please mute your mic.
Okay. So now, as a young researcher, always your ambition is to publish in a high impact factor journal which has got a very good metrics, so that decision-making bodies will notice that work. Right? So now you will be hesitant to publish in an open access journal. Definitely, it will have a low metrics because it is a recent trend which has started. So what you can do, you can also make this. Of course, I'm getting my funding from the government or a public funding. So how do you make it? How do you satisfy both the criteria? Of course, you can go ahead and publish in your reputed journal, which is published by a commercial publisher. At the same time, you can deposit this paper in your institution repository. That is called a green open access publishing. So you may ask now, what will be the copyright, right? So there may be a violation of copyright. Once this open access model started picking up, publishers also started relaxing their copyright. So now various publishers allow you to put your preprint, not exactly the publisher version, the first draft of your paper. So without reviewing and all, no, that is called preprint. And some publishers are allowing you to put a postprint where reviewer comments has been incorporated. And some society publishers, they tell you, okay, you can go ahead with the author final version with all publisher tags, formatting, everything done. And some publishers are even like, you can put it publisher copy, not now, maybe after 1 year, called embargo period. So in 1 year, I will make my money. Then I will allow you to put it on your own institution repository, the full final copy of that paper. So like that, various provisions has been made by publishers to put it on institution repository, which is called as a green open access publishing. Now publishers saw this open access publishing started gaining momentum and it's gaining popular. So once everything becomes open access, all researchers start publishing on open access platforms, definitely there is a threat for publisher revenue. So they started with the author pay open access publishing. Okay. So what they do, instead of charging readers, they started charging the authors, right? So as an author, if I want to publish in open access on a commercial publisher platform, I have to pay somewhere around $2,000 to $3,000 based on their publisher price tag. So individual author definitely cannot afford, especially authors from developing countries like India. We may not be able to afford these author pay charges on open access domain. Why people are interested to publish on open access domain? As an author, I always, my rewards are my metrics. How many people have cited my paper? What is my H index, right? What is my site score? So these are the various metrics as an author that I get. I may not get any monetary benefit from the publisher who makes lots of money, right? So if I publish in open access publishing platforms, chances of getting more citations, chances of accessing my research work by a larger community is more, right? For example, if you publish in a highly priced journals like Elsewhere and IEEE, etc., etc., So the underdeveloped countries who are looking at this kind of research information may be denied because they may not be able to afford that. Okay, so that is the advantage. That is why many open access people are encouraging open access publishing. Now, in author pay charges for commercial publisher, definitely as a developing country, we will not be able to offer. So, what was the solution? Again, the funding agencies started supporting this. For example, when you proposing a project proposal to any funding agency like DST or DBT or any international funding agencies, you can allocate some provision for publishing charges, author pay publishing charges, and many, if not all, publishing funding agencies, many publishing agencies are now allocating some budgetary allocation for this author publishing. And as a DST, as a Department of Science and Technology, we have a clear-cut guidelines that whatever work we publish should be uploaded to our repositories. In later part of the presentation, I will show CSIR open access repositories where we are trying to archive all our publications on institution repository. This is about open access publishing. Okay, and like any other area, you see a lot of gray areas where people want to misuse that initiative or misuse that model to make money in shortcuts. Like, so when people saw this author pay model was getting momentum, many researchers started paying author pay charges. Many predatory open access publishing journals started. What do you mean by predatory publishing? Predatory publishing journals intention is only to make money. They take you some publishing charges. They will not make any value addition. Okay, there won't be any review process. So okay, so just like that they will publish. So as an author, you should be very careful to publish there, and also as an author you should be very careful to refer that, because there is no authenticity in that particular research information, because it is not reviewed by any expert committees. So whatever authors sends, so they will publish. So these are called predatory open access publishing. So how do you know it's a genuine open access publishing where, or it's a predatory open access publishing? Again, it is author's responsibility to go through that. So there are various guidelines. There is something called the Directory of Open Access Journal, where they evaluate this open access journal and they have listed there. You can always look at that open access Directory of Open Access Journal. And there are various international committees who look after this publishing ethics, like a committee on publishing ethics. There is a committee on STM. There is OASPA committee. They have certain guidelines for a journal to follow. Okay, and also you always look at the editorial, who are there in the editorialship and who is publishing. If that open access journal is publishing by a reputed institute, you can always rely on that. And a lot of times these predatory journals mislead authors, and their names will be like always international in nature, International Journal of so and so, so and so, and their metrics they display on their websites is unbelievable. Their impact factor says 40, 50. There is no end. So you should be very careful in publishing as well as reading those or citing those resources, because it lacks an authenticity. Okay. So as I was telling you, DOAJ, it's a Directory of Open Access Journal. Currently there are 14,000 open access journal has been listed there. The to list here, they have an evaluation criteria, so that once these open access journal meets that criteria, they will include there. So if you want to publish any open access journal, or if you want to use any open access content, it's always better to consult DOAJ and get hold of that. And for example, these 40,000 journals are published by 133 countries, and it has got more than 5 million articles indexed, and you can search at article level. Okay, if you search DOAJ, you can search, and there are 283 exclusive engineering journal and 342 science journals are available. Of course, social science journals are more on open access domain. So I was telling one more category of open source platform, that's green open access. For example, all the reputed institutes, universities, now they have come out with these open access repositories where their scientists will publish with the high reputed journal, high impact factor journal, which are commercial in nature. but the author copy they deposit in their institution repository. Like that, there are directories of this kind of repository called Row Registry of Open Access Repository, where they have listed 4,000 institutional repositories established by various universities and institutes. Similarly, you have a directory of open access repositories, which has got 2,900 repositories. So what you can do, for example, if you are interested in MIT repository, Massachusetts Institute of Technology repository, they have set up their repository and they have archived entire their publications. You can search here MIT repository, then it will take you to the MIT repository. So you can make use of these platforms. And for example, I am the most beneficiary of these repositories. In our NAL itself, we have a project on integrated vehicle health management. So IVHM, there is a Center for Excellence of Integrated Vehicle Health Management at Cranfield University. So they have established their repository and they have archived entire their publications. For example, more than 10,000 research articles they have archived there. So whenever I wanted to data or articles related to IVHM, straight away I go here and whatever new research publication they published, I download from here. These 10,000 published papers are published in various commercial publishers. They have archived as per their copyright law, copyright provisions, and they have not stopped there. They have also archived the data sets. So when I say data sets, the supporting documents, for example, statistical data or drawings or flow charts of a project related. So these are the very crucial information which you may not get on general search engines, right? So you can go there, you can just download that. Of course, some repositories may ask user ID password because of copyright issues. Definitely they have a provision called request a copy. Once you request, and if it is a research and education purpose, which is under fair use class of copyright, they definitely send you. Only thing is you're not supposed to make commercial output from that. So that's the requirement. So you can always consult institution repository. There is one more a subject repository, preprint repository called argsv.org by Cornell University, where they claim they have more than 1 million records, preprints, which may be published in various journals, and there may be unpublished reports, unpublished papers also they have archived. Mainly they cover on physics, mathematics, computer science, and quantitative finance, statistics, etc. And as far as Indian open access institution repositories, we have a IAC repositories, which is the first institutional open access repositories established way back in 2001. They have archived around 4,000 plus publications. We have a QSAT, we have IIT. There are so many initiatives. I have taken only a few institutional repositories from India. And we come across one more data source like thesis platforms, where there are a lot of global and national level initiatives are happening, where they are trying to archive all PhD and master's degree theses. For example, NDLTD is an international initiative where they are archiving this doctoral, postdoctoral, and master thesis. And if you search NDLTD, you will be searching more than 5 million theses, which contains again a primary source of information which you can make use of. And there is one more initiative called Dark Europe e-thesis initiative, where they have more than 7 lakh thesis has been archived. And we have again one more MHRD funded initiative like Shodh Ganga. Now all Indian universities have been mandated to submit a 1 copy of thesis to Shodh Ganga to archive as a national thesis repository. And right now there are more than 2 lakh thesis has been already archived. So you can always search for your area of research. And also VTU last year again they have taken up an initiative to archive all VTU theses and master's degree dissertations or theses what they submit to VTU, and also they are planning to integrate with that plagiarism tool what they are subscribing, so that the similarity of the plagiarism issue will be reduced to least possible percentage. So as I told you, since we are funded by Ministry of Science and Technology, we have a mandate that all CSIR labs should make their publication in open access channel. If not in gold open access, it should be an green open access. Like every CSIR lab has to set up an institutional repository, and like that all CSIR labs have started setting up institutional repository and started depositing all their papers there. And we have a centralized harvester called CSIR Central, where it harvests data from all CSIR lab and makes it in a single platform for end user search. Similarly, DST, we have around 23 to 24 laboratories. They are also started an initiative called Science Central, where all DST laboratories content, papers published and scholarly publications will be made available on green open access channel. And there are one more type of information resources called gray literature. Of course, these are not again a peer-reviewed one. Again, it's up to individual author to judge the authenticity of that. But nowadays, because of this digital technologies, now accessing to any content is easy, right? So just you need to host on some server so that anybody can access from anywhere. So with this advantage, many organizations are coming up. Many international initiatives are coming up to archive gray literature. When I say gray literature, it's again a scholarly data, first-hand scientific data generated at laboratory level, maybe project reports, maybe survey reports, or maybe some government reports, laboratory notes, etc. etc. There are 150 category of gray reports, gray literature which are available, and there are now various platforms have started to archive this gray literature so that you can refer that. For example, one important gray literature document is data sets, the statistical data what you get from your experiments and all. So this kind of data, many universities or many initiatives like GrayNet Area, Open Gray or HL repository, they started capturing this kind of content and making it available on internet free of cost. So definitely you should be very cautious to refer to cite or to make use of this kind of resources. Okay, but these are the best sources for scientific data or scientific literature also. So this is about the way of identifying resources or narrowing down your research area, resource problem, or understanding your research area by going through a scholarly literature available on various platforms. So you can also have one more approach called patent resources, right? So always you can look at patent databases and look at the patentability of your research, whether really it is worthwhile to invest money. Because when you take up a research, you will be investing time, money, resources, manpower, so on, right? Whether this particular area is really worth. As morning, Dr. Ashwath was mentioning that we need to address the social problem, the societal problems. So for the main objective of any research is to address the societal needs, right? So at the end of your research, it should be beneficial for the society. It should make your living standard more easy, right? So that's the ultimate objective of any research. So before pursuing any research or identifying a research area, it's always advisable to consult patent databases, do patentability search or novelty search, and then narrow down your research area. So how do you do? What are the resources available? Let's see what are the resources available as a patent resources. So before that, why you need to do this strategy? Of course, any research involves a lot of investment, either in terms of money, manpower, or infrastructure, right? So end of the day, once you complete your research, your investment should not go waste. And there is a high cost in maintaining patents. For example, once you file a patent, you have to pay patent charges to maintain that. And it helps to find out a novelty. For example, without doing any patent search, you started a research area. So you also reached in the final stage of your research. Somebody else already finished that area and filed a patent. Then you cannot claim on that, right? So then it will be a waste of a lot of money, lot of resources. And also it helps you to identify the white spaces where that gap, the research gap is there. Okay, so all this can be done through your novelty search. and also for an institution, for a decision-making body, it will help us to strategize our investments for as far as the institution is concerned, and also it will help us to avoid the future litigations. For example, once you thoroughly do your novelty or prior art search and start your research, and you can claim that you are the first person to start that. Okay. So what are the resources available for you? I told you as a patent, as an information, it is free. If you go to USPTO, it is free. European patents free, right? Japan patents free. But there are commercial databases which allow you to landscape, which allow you to make a lot of analytics on their platform. So they charge for that value added service, not for the content. For a free patent databases, we have a Google Patents, we have a USPTO, entire US patents are free there. You have a European patents, right? You have Indian patents called INPAS, and there is one aggregator of patents called Free Patent Online. Only you need to register once. They give you user ID password, and you can search any patent as an information. But if you want to do a landscaping, if you want to do a analytics, you need to go for a commercial patent databases. Like you have a popular patent databases called Thomson Innovations. You have a Coastal Arbit, it's again quite popular one. We have a Excel Pad. From IEEE, you have a IEEE Innovation Q+. And we have a PatSnap. In NAL, we have access to PatSnap. So I have done some patent landscaping so that how you can do with that. And I will show that example, how it will be helpful to narrow down my research area. So this is patent landscaping. So I'm interested in my research area, which is driverless cars. Okay, smart cars and driverless cars, where you will have an autopilot kind of a mechanism. So I want to see how this particular area, what are the trends in this driverless cars? So what are the landscapes? So to have this landscape, again, they use a patent data, how many patents has been filed, how many patents has been granted, etc., etc. And you can see these hilly areas. These are the places where a lot of patents has been already filed. For example, traveling, obstacle avoidance, unmanned guided steering. There are already a lot of work is already going on. But if you see these counters, that low areas where there is not much research happening, maybe if you can identify some research area in that and start working on that, there is a more chances of having a patentability there, and you can commercialize that research work, right? Like this, you have car navigation, a lot of work has been already going on. So this is how we can do a landscaping. Of course, in 1.5 hours is very short time to have a this kind of exposure to this kind of resources. Maybe it needs one day workshop kind of a thing, that so that you can really explore, you can really become somewhat experts. What I'm trying to do is to introduce the sources which are available. So when you go back, if you start exploring, then you will get familiarized with those kind of platforms. So these are the word cloud. If larger the word cloud, more number of patents on that particular area. For example, autonomous driving, lot of patents has been already filed, and driverless cars. Again, this particular platform has extracted these phrases or keywords present in number of patents, and it is linking, right? For example, how the growth car concept somewhere started in 2000, filing happens. Now it has reached a peak at 2015. Now a lot of activities are going on, right? So you can see this is the current area where you can really invest, where you can really put your, you can identify your research problem. So that you will have a patent. It's echoing. And also, you can also have a geographical comparison, right? Who is investing more? Which country is going ahead in patenting in this particular driverless car area? So you can also compare. In India, somewhere we are started and we are lagging behind. Of course, China is a front runner in this particular area where they are investing a lot of money on this research. and next to that is US and Germany. They are investing. Japan also they are investing. So that maybe if you want to identify a collaborating partner in some other country, this information will be useful for you. And who are all the companies who are investing on this? Robert Bosch have filed almost 36 patents in this particular area. Okay, if you click on this bar chart, it will take you to the 36 patents. Similarly, Hardy and Hyundai. Hyundai is the second largest company who are investing in this particular area of research. And this is a technology innovation wheel where it has identified subtopics in this domain of driverless cars, like autonomous navigation and how this automatic parking should happen, and autonomous driving, driverless car, controlled car, and you have a secondary subtopics like these are the various areas you can identify. You can pick up one and you can start exploring patents on that, and what is the new area where you should pursue your research. So you can identify that particular area of research for you. And also PatSnap, I don't know with other patenting platform, PatSnap also give you the market potentiality down the line 10 years. If you invest money now, so what will be the gain? This data is taken by, again, they have a tie-up with some marketing research agencies, and they consult a lot of their annual reports, and they predict this may be the market potentiality of this particular patent. For example, Audi has filed a patent on autonomous operation of a motor vehicle in a car wash. So it has got a potentiality of market potential of $12 million in 7 years. Estimation lifespan is 7 years, and their revenue expected is this, and they have a simple family of 5 patents of this category of patents. So this is how you can make use of patent resources to narrow down your research area. And as Professor Venkatesh Shivaralu morning was telling about a lot of funding agencies and how to apply. So I have 3 to 4 resources where you can look at who are all the funding agencies in your field. So how to know the list of funding agencies so that you can go back to their particular website and exploring the terms and conditions and which area they fund, they do research funding. So one source, as I told you, is Scopus. They also can, apart from capturing
really, the way of presentation is very excellent.
So capturing relevant bibliographic details, they also. Sir, please kindly mute your microphone.
The way of presentation is very excellent.
Sir, please mute your.
Sir, the participants, please request the participant to mute your audio.
Okay, so as I told you, if you do a search on Scopus platform, like I'm working in the surface coding area, and I'm looking for a research grant, and I should know what are the research funding agencies where I can go and tap these funding agencies. So you can always search for your topic or your broader subject area, and they have something a filter called funding filter. Once you click on funding filter, for example, surface coating would have retrieved around 20,000 articles, and if I click on funding filter, it lists out all funding agencies who have funded these particular articles, research work which they have published. For example, the first window gives you the international funding agencies. Of course, they may have funding policies that they will fund only their countrymen, or some funding agencies maybe cross-country funding opportunities and all. And also they have one more filter category called country or geographical territory. If you do that, if you restrict to India, it will list all funding agencies for surface coating research area. For example, Department of Science and Technology, Government of Kerala, they have with their funding around 2,500 articles on surface coating has been published and indexed on Google on Scopus. Similarly, you have a DST, you have so many other University Grants Commission, UGC, AICTE, Science and Engineering Research Board. So you will come to know how many articles from this research funding has been published. So when you can go back to these funding agencies, and also you can look at their funding policies, as Professor Venkatesh was telling, whether they really fund basic research, whether they really fund applied research, and whether really they fund the technologies or infrastructure. You can always explore that. So critical information here is this: you will get a list of funding agencies, right? Similarly, you have one more platform, as I told you, citation platform, Web of Science. They also has got a funding filter. So when you search for your broader subject and apply this funding filter, you will come to know who are all the funding agencies. Maybe you can pick which are in your geographical territory, or which are some NGOs which may provide a collaborative research work. So all those possibilities as a researcher you can explore. Okay, and of course these two are a paid platforms. Of course you need to have a subscription to that. There is one more platform called Mendeley. Okay, Mendeley is again a Elsevier product, but it is free to use. Only thing is you have to register once with your email ID, and they give a lot of other functionalities apart from funding information, like you can have your own personal library, reference management tool kind of thing, and they have give access to a lot of data sets which are been aggregated from various platforms. And they have one tab called funding agency. Once you click that, right now they have a funding information of 21,000 possibilities. Of course, these funding types may be your research funding, or maybe travel grants, or maybe fellowships, and so on. So you can always search on funding type. You can always search on the subject areas, and also you can search on country wise. Right now, there's a funding agencies for engineering is 1,035 active funding agencies are providing that. So if you click on that, if you're looking for mechanical engineering, if you're looking for a material science, you can narrow down that. I'm not saying you will get everything, but you can give a try. This is the one source as a source for funding you can see. And we have one more MHRD initiated project for Vidwan. Maybe you may be aware of it. So objective of Vidwan is collect all scholarly output, including personal profile of Indian academicians and researchers on single platform, including their publications, the project executed by them, and all their achievements like awards, members to various committees. All those information can be created here, and it is free to register for all academicians and researchers. And here they have one clause called research projects handled by a particular researcher, where you can tap a funding agency who has funded for him to execute that project. And also it also gives you the collaborative partnership opportunity. For example, if you are working on surface coating, you can narrow down the who are the Indian experts, which are the Indian institutions who are working on surface coating, and you can approach them to have a collaborative work. They may have a better infrastructure, better testing facilities. Okay, maybe you can always collaborate with them. That kind of information you can draw from this Vidwan database. I request all participants to register there and create their profile. And also their objective is to look at this database before awarding any award, professional award, or sanctioning any research project. So ultimate objective of this platform is that. So they want to make a single database, national database, where all kind of scholarly information should be available. Okay. And we have one more platform called RCID platform. Again, it's an international initiative where you can create your profile. And many international funding agencies, they are looking at RCID for your researcher credentials, like how many papers he has published, how many projects he has executed, and what are his scholarly metrics, how many citations he has got, what is his H-index, all those data, you can create it on RCID, right? So these are the various sources available for researchers to understand his research, to get hold of a research content which is there in his domain. Apart from this, as a researcher, you can also make use of these tools. Due to shortage of time, I may not be able to go into detail, but I will give you surface level information on what is the purpose of these tools, which researchers, and most of them are free. Of course, some are priced one. like automatic alerts. For example, I told my research area is surface coating, and I have identified 10 journals which are core in my surface coating area, published by various publishers. Okay, now I should have a tool. It should automatically tell on my device, this is the new papers published from these 10 journals. So automatically it should come to my desktop or my device. So to achieve that, there are something called RSS feeds, where each publisher for each journal, they will have a RSS feeds. Okay, so you have to subscribe once and install this particular feed reader software on your device and subscribe one. And if you have an internet and you set an automatic update weekly or quarterly or monthly, the journal publishers, automatically all those articles will come and land in your device, in your desktop. So those are called automatic alerts like RSS feeders. And we have one type of tools called reference management tools. For example, now in the olden days, like we used to take printout of all our journal articles and file it in a physical way, physical filing we used to make. Now we are getting everything in digital mode. We are downloading them as a PDF. And what we are doing, we lack of organizing this. Okay, we store it in some folder, and to retrieve again, we spend a lot of time, right? We wasting a lot of time, which is there in our system. So to address this issue, there are various softwares called reference management tools. To say Mendeley, which is a free tool, Zotero, which is an open source tool. You have an EndNote, you have a RefWork, Ref Manager, so many tools by using which you can create your personal digital library on your device, and you can easily retrieve the documents which you collected. And one more tools are called journal selection tool. Often we find very difficulty to identify a journal to publish our article. Though our research is very good, if we fail to identify a right journal, we will end up in publishing in some low impact factor or low metric journal. So there are various third party and publisher dependent tools. We can make use of that. And since we are a non-English speaking population, what we do, our research language, research reporting language is very poor, and 50 to 60% of our papers, though our research is very good, gets rejected because of our language. What we try to do is we write Kannada in English. So our thoughts are all will come in Kannada. We'll translate or transcript them in English so that the sentence formation or whatever the editorial or reviewers are expecting, they may fail to read your ideas or what you want to communicate. So there are various research language assisting tools like Grammarly, Paperwriter, Ginger, etc. So which you can make use and improve your research language. There are again author ambiguity. For example, Indian authors are named as various ways, like first author, last author, last author, first author. By having this ambiguity, you will lose the citation matrix, right? When it is indexed in Scopus, it will index as two different names. So your citations get scattered. And also, we need to, as a researcher, you need to know what rights, author rights you have, and what is copyright infringements. And now the plagiarism is a big issue now. So there are various tools to check similarity. And there are infographic tools. Infographic tools is a tools which help you to represent your research results in more graphical way, more pictorial way, so that you can have an effective communication to the audience. I think these are the various tools as a researcher you should look for, and you should try to adapt in your day-to-day research so that you will be saving substantial time. I think that's all from my side. Thank you very much for your patient hearing, and thank you for the opportunity to share my little learnings with you. If you have any questions, I will be happy to answer.
Thank you, Shivaram sir. Any questions, participants? Sir, there is one question with reference to RSS feeders.
Yes, sir.
Can you please share some information on
RSS feeder is a type of web application. So there are browser-based RSS feeders, and there are desktop applications. I will say take one example and show you. Like if you go to Science Direct or any journal, say 1 second. I will just open some publisher site and For example, my research area is power electronics or IEEE transaction on power electronics is my core journal, right? So what I'll do, IEEE journal on power electronics. So I'll go to this journal site. So this is an RSS feed, okay? So I will install a feeder on my desktop and I will just copy this this URL once in my RSS feeder, and whenever I refresh that feeder, so whatever new article, this journal automatically comes to my desktop without I am going to particular journal web page. For example, I have identified 10 journals in this power electronics area, and I will subscribe all these RSS feeds of all the 10 journals. So automatically the table of contents of these journals will come to my device or my desktop. So it saves a lot of time. Like you can also set up particular topic in these things. If you install a desktop version, like RSS OL is a popular RSS feed reader. So if you do that, it will you will have a digital your personal library kind of a window there, and each journal you can click. So it will display table of contents up to abstract level. And if you are interested in that abstract, you can directly click on that full text link. It goes to IEEE site. If you have access, you can download that. That's the privilege you get using RSS feeders. That's what I mean.
Sir, there is one more query. Sir, which is the ideal management tool you would suggest?
Reference management tool?
Language tools or grammar tools is what they're asking. Open source.
See, in NAL we have a access to Grammarly, and we are satisfied with functionality. But at the end of a day, it can only suggest. Okay, these are all only suggesting tool as far as grammar is concerned. What it does is it addresses various syntax, spelling error, past tense, future tense, active voice, passive voice, and all. So all publisher expects articles in active voice and present tense kind of a thing. So it will suggest you to modify, but at the end of a day, you should be able to, you should be convinced to take that suggestion. Or if you feel you are right, you can go ahead. But we are using Grammarly here, and we are quite satisfied for that. But I'm not here to make any advocate any particular tool. Like as an end user, whichever is comfortable for you, you should go for that. We are using Grammarly at our institute. As far as the reference management, of course, there are various commercial reference management tools, but Mendeley is free. Mendeley is really good. So I am a user of Mendeley, and wherever I go, I also educate research participants about Mendeley. And Zotero is also an open source tool. Of course, functionality wise, when you compare to Mendeley, somewhere Mendeley has got edge. So it's again a desktop version is free, web version is free. You can integrate both desktop and web version, and you can make use of Mendeley. I think Mendeley as far as reference management.
Sir, there is a general question. Is Vidwan giving latest research topics is what the participants?
As I told you, Vidwan is a profile creating platform. Okay. So latest information, it also gives you a search interface where you have to do some trial and error, like what are the latest projects executed by researchers. In that way, you can narrow down. But basically, it's a profile creating platform.
Okay, sir. Thank you so much. Thank you, Dr. Shivaram B S. Okay, it was indeed a very interesting and informative session. More than 365 participants have participated today. Most of them have expressed their happiness with reference to the information that you have shared to them. Thank you so much for associating with Bangalore Institute of Technology, sir.
Thank you very much. I would like to thank Venkatesh Shurlu and the BIT authorities for giving me this chance to share my little. Thank you very much.
Thank you, sir. Thank you. Participants, the feedback is given in the WhatsApp group. Kindly fill up the feedback.
Sir, done, sir.
Deepak, can I take over? Deepak, can I?
Yes, sir. I request Professor Krishna Prasad sir to render the vote of thanks.
As you know, should know the application and where to and who want what. For that, so the platform, that is how to access the source and what are the platform required for the access and what are the repositories are there and overall got the patent and what is required to work, who are all the aggregators, everything, all the platforms, it is explained neatly by Shivaram sir. So I am thanking very much for Shivaram B S, Senior Technical Officer, to explain all the platform. Thank you, sir.
Thank you, participants. Tomorrow we are meeting at 10:30 once again.